Hello everyone. The F-35 is a family of single-engine, supersonic, stealth multirole fighters. The second fifth-generation fighter to enter U.S. service and the first operational supersonic stealth fighter. The F-35 emphasizes low observables, advanced avionics, and sensor fusion that enable a high level of situational awareness and long-range lethality. The USAF considers the aircraft its primary strike fighter for conducting suppression of enemy air defense missions, owing to the advanced sensors and mission systems. The F-35 has a wingtail configuration with two vertical stabilizers canted for stealth. Flight control surfaces include leading-edge flaps, flaperons, rudders, and all-moving horizontal tail stabilators. Leading-edge root extensions also run forwards to the inlets. The relatively short 35-foot wingspan of the F-35A and F-35B is set by the requirement to fit inside U.S. and amphibious assault ship parking areas and elevators. The F-35 coulombs larger wing is more fuel efficient. The fixed diverterless supersonic inlets use a bumped compression surface and forward-swept cowl to shed the boundary layer of the forebody away from the inlets, which form a E-duct for the engine. Structurally, the F-35 drew upon lessons from the F-22. Composites comprise 35% of airframe weight, with the majority being bismuth and composite epoxy materials, as well as some carbon nanotube reinforced epoxy in later production lots. The F-35 is considerably heavier than the lightweight fighters it replaces, with the lightest variant having an empty weight of 29,300 pounds, 13,300 kilograms. Much of the weight can be attributed to the internal weapons bays and the extensive avionics carried. While lacking the raw performance of the larger twin-engine F-22, the F-35 has kinematics competitive with fourth-generation fighters such as the F-16 and F-18, especially with ordnance mounted because the F-35's internal weapons carriage eliminates parasitic drag from external stores. All variants have a top speed of Mach 1.6, attainable with full internal payload. The powerful F-135 engine gives good subsonic acceleration and energy, with supersonic dash and afterburner. The large stabilators, leading-edge extensions and flaps, and canted rudders provide excellent high alpha angle low fat act characteristics, with a trimmed alpha of 50 degrees. Relaxed stability and triplex redundant fly-by-wire controls provide excellent handling qualities and departure resistance. Having over double the F-16's internal fuel, the F-35 has a considerably greater combat radius, while stealth also enables a more efficient mission flight profile. The F-35's mission systems are among the most complex aspects of the aircraft. The avionics and sensor fusion are designed to enhance the pilot's situational awareness and command and control capabilities and facilitate network-centric warfare. Key sensors include the Northrop Grumman ANSLASH-AP JD-1 active electronically scanned array radar, BAE Systems AN/ASC-239 Barracuda electronic warfare system, Northrop Grumman/Raytheon AN/OC-37 electro-optical distributed aperture system, Lockheed Martin AN/OC-40 electro-optical targeting system, and Northrop Grumman AN/ASC-242 communications, navigation, and identification CNI suite. The F-35 was designed with sensor intercommunication to provide a cohesive image of the local battle space and availability for any possible use and combination with one another. For example, the AP JD-1 radar also acts as a part of the electronic warfare system. Much of the F-35's software was developed in C and C++ programming languages, while ADIL-83 code from the F-22 was also used. The Block 3 Farad software has 8.6 million lines of code. The Green Hills Software Integrity DO 178B real-time operating system runs on integrated core processors. Data networking includes the IEEE 1394B and fiber channel buses. To enable fleet software upgrades for the software-defined radio systems and greater upgrade flexibility and affordability, the avionics use commercial off-the-shelf components when practical. The mission systems software, particularly for sensor fusion, was one of the program's most difficult parts and responsible for substantial program delays. The APJD-1 radar uses electronic scanning for rapid beam agility and incorporates passive and active air-to-air modes, strike modes, and synthetic aperture radar SAR capability, with multiple target track while scan at ranges in excess of 80 nmi 150 kilometers. The antenna is tilted backwards for stealth. Complementing the radar is the OC-37 DAS, which consists of 6 infrared sensors that provide all-aspect missile launch warning and target tracking. The DAS acts as a situational awareness infrared search and track, and gives the pilot spherical infrared and night vision imagery on the helmet visor. The ASQ-239 Barracuda electronic warfare system has 10 radio frequency antennas embedded into the edges of the wing and tail for all-aspect radar warning receiver. It also provides sensor fusion of radio frequency and infrared tracking functions, geolocation threat targeting, and multispectral image countermeasures for self-defense against missiles. The electronic warfare system is capable of detecting and jamming hostile radars. The AAQ-40 EOTS is mounted internally behind a faceted low observable window under the nose and performs laser targeting, forward-looking infrared, and long-range burst functions. The AS-Quiminus 242 Coulomb NI suite uses a half-dozen different physical links, including the directional multifunction advanced data link for covert CNI functions. Through sensor fusion, information from radio frequency receivers and infrared sensors are combined to form a single tactical picture for the pilot. The all-aspect target direction and identification can be shared via MADL to other platforms without compromising low observability, while Link 16 is present for communication with legacy systems. The F-35 was designed from the outset to incorporate improved processors, sensors, and software enhancements over its lifespan. Technology Refresh 3, which includes a new core processor and a new cockpit display, is planned for Lot 15 aircraft. Lockheed Martin has offered the advanced EOTS for the Block 4 configuration. The improved sensor fits into the same area as the baseline EOTS with minimal changes. In June 2018, Lockheed Martin picked Raytheon for improved DAS. The USAF has studied the potential for the F-35 to orchestrate attacks by unmanned combat aerial vehicles via its sensors and communications equipment. A new radar called the APJD-5 is planned for Block 4 Farrads 35s. According to the JPO, the new radar will be compatible with all 3 major F-35 variants. However, it is unclear if older aircraft will be retrofitted with the new radar. Stealth is a key aspect of the F-35's design, and radar cross-section is minimized through careful shaping of the airframe and the use of radar-absorbent materials RAM. Visible measures to reduce RCS include alignment of edges, serration of skin panels, and the masking of the engine face and turbine. Additionally, the F-35's diverterless supersonic inlet uses a compression bump and forward swept cowl rather than a splitter gap or bleed system to divert the boundary layer away from the inlet duct, eliminating the diverter cavity and further reducing radar signature. The RCS of the F-35 has been characterized as lower than a metal golf ball at certain frequencies and angles. In some conditions, the F-35 compares favorably to the F-22 in stealth. For maintainability, the F-35's stealth design took lessons learned from prior stealth aircraft such as the F-22. The F-35's radar-absorbent fiber matte skin is more durable and requires less maintenance than older topcoats. The aircraft also has reduced infrared and visual signatures as well as strict controls of radio frequency emitters to prevent their detection.